VLSos here. This is a video lesson on the graph of sine. I have a computer program here. We could imagine that there is a very special Ferris wheel. And this Ferris wheel is special because the ticket booth, where you buy a ticket and board a gondola to go for a ride, is at ground level, which means that for half of the ride, we go around up in the air and reach a high point. And halfway around the circle, we come back down to ground level. And to complete the ride, we have to go underground to come back to the ticket booth at ground level. The engineering of a ride as sophisticated as this, we could imagine, makes the ride break down on occasion. And when it breaks down, we need a ladder to get out of the gondola and climb back to ground level. If we're in the air, that ladder has a length we climb down. But if we're below ground, we'll still need a ladder to climb up to ground level. So dependent on where you are when the ride stops, you'll need a different size ladder to get out and get back to ground level. There is a mathematical relationship between the length of the ladder needed and where the gondola is on the circle. And to investigate that mathematical relationship, we could imagine a radius that connects the center of the circle to the point is being swept at an angle as the gondola or the point travels around the circle. The angle in degrees that is being measured by the program is the angle between the starting position, or the positive x-axis, and where the radius line is on the circle. So as the point travels along, it begins at a very small angle measure. The angle measure at the top of the ride is 90 degrees because it's the angle between the starting position and the radius. And we can see that the angle will continue to go from 0 to 180 degrees halfway around the circle, and then up to 360 degrees before it resets and the point travels another way around the circle. The length of the ladder is the same thing as the vertical distance of the point to the horizontal axis. We could graph the vertical distance as a function of the angle of rotation. On this graph, the vertical axis is the same thing as the length of the ladder. We can see that the ladder is drawn from both points, and the height of those points connected by the green line is the same. The horizontal axis is the angle measure, and as the angle measure gets up to 360 degrees, a full circle, we can see that the graph resets as the point travels around the circle again. The mathematical relationship between the vertical distance of the point and the angle is the sine function. In this case, we can see that the coordinates of the point that is being graphed is a function of sine. The y value is the sine of the angle of rotation. And if we were to graph all of those ladder lengths, all of those vertical distances, all at once, it would create this curve that we call a sinusoidal curve. That sinusoidal curve is the graph of sine.